Good morning, friends. We are learning our subject that is data mining 3160714. And in that, we are learning the chapter 3 that is concept description and association rule mining. So, what we have learned in the last lecture that what is concept description and how to generate automatic concept description hierarchy, isn't it? You remember that? Yes, this is automatic concept description hierarchy, isn't it? This generation we have done yesterday, right? We can say country is the higher level concept, then state, then city, then street, right? And we have said that automatic concept hierarchy generation is not always possible, where we can say something like this: weekday, month, quarter, year, right? Here, because the number of distinct values, they are not in the sorted way, the way the concept hierarchy should be there, right? Okay, so that was the summary of previous lecture. Now let us see. We are learning concept description, isn't it? So, how to describe that also we have seen. That is, we have taken one simple diagram and we have represented the concept of cells. If you want to see, I can show you that, right? This concept description we have seen. For concept of cells, we have said it is having say computer and printer. For concept of computer, sorry, concept description we have seen. For concept of cells, we have said it is having say computer and printer. For concept of computer, sorry, customer, we have considered low budget and high budget. You can say, is it only that? Don't we have anything more than that? See, we can have. Here, what we represent is whatever is our perspective, whatever is required to us for that particular application. Fine. So concept description, how to describe that? That is now known to you. And how to generate the concept hierarchy, that is also known to you. Fine. So let us proceed further. This description can be divided using three types. What are these three types? We have seen these two things in the previous chapter where we have seen the DMQL for all these things, right? So now let us see in detail what these things are. Okay. Data characterization, concise summarization of data of class under study. Concise summarization of data of class under study, right? Data discrimination. What is that? Comparing two or more sets of data of classes, right? Summarization, that is characterization, when we compare two or more sets of classes, is called the discrimination. Okay. And the third class is, we can say, third class, I mean to say that the third type is both data characterization and discrimination, right? So one is characterization, second is discrimination, and third is mix of both. Okay. So now we want to see the examples of all these types, right? So let us see data characterization example. What do we see about that? A customer relationship manager may order the following data mining task. Now, what is the data mining task we consider here? That is, summarize the characteristics of two customers who span more than say 5 lakh per month, who spend more than 5 lakh per month. We want to summarize the characteristics of customers who spend more than 5 lakh per month. The result is general profile of customers such that they are 40 to 50 years old, employed, have excellent credit ratings, isn't it? See, this is the typical thing. Who can spend more than 5 lakh per month? They must be employed or not. Then too, they have excellent credit ratings, right? So people who are rich, and a person typically is rich when that person is having the age in 40 to 50. We can say that, say, rich persons, sons or daughters, they will also spend this much, right? So can we say those children are also included here? That can be if we do have such data, right? So whatever the data, this example people have considered, in that they have seen the result of what? Summarize the characteristics of customers who spend more than 5 lakh per month, right? So for that, the general profile of the customers say that they are having the age between 40 to 50, employed, and have excellent credit ratings. Fine? Okay. The data mining system should allow the customer relationship manager to drill down on any dimension, such as on occupation, to view the customers according to their type of employment. See, here this is ideal condition, that is, the data mining system should allow the customer relationship manager, whoever is the manager, to drill down on any dimension. That is, that person should be able to see any particular dimension, any particular column in detail. For drill down, we say that if a person is customer, then we can say that for his occupation, whether the person is employed or not, that is employed somewhere or not. If that person is employed, then how much salary that person is having, or what type of employment that person is having. Is he having government job? Is he having private job? What sort of things in detail, that person detail we should be able to have, right? We means me, you know, the customer relationship manager, right? One thing is, see, this is the ideal scenario. If we have such data, we will be able to drill down. Fine. But many a times it is the case that people are not ready to provide the data, right? They are not ready to provide the data. So at that time, we not be getting all these things. We are talking of the scenario where we do have all the information available to us, right? Data discrimination example. So for this, can I say that we will not be able to get the data? See, whatever data is available, from that we will summarize. Okay? Whatever data is available, from that we will summarize. Okay, if you have the data of customer till occupation level, we do not have the data for government or private job, then fine. If we do have the data till only employment, we'll consider that. And if we do not have the data for other things, we cannot get, isn't it? But we will get the summary for this particular example, right? So characteristics of the customers we got, and that is what is the characterization. Let us go to the next topic, that is data discrimination example. A customer relationship manager may want to compare two groups of customers. Those who shop for computer products regularly, that is for example, more than twice a month. More than twice a month. Second is those who rarely shop for such products as for example less than 3 times a year. In the first, we have considered the group where a person buys computer products twice a month. This is month and this is year, right? And here the group considers rarely shop the products, right? The customers who rarely shop the products, right? So we are having these two groups, and say customer relationship manager want to compare these two groups, right? So what we can say is this is the data discrimination example, isn't it? Now, data summarization. It is useful to be able to summarize a large data set and present it at a higher level conceptual level. It requires important functionality, that is generalization, right? Now, data generalization and summarization based characterization. So what do we say about the data generalization? A process which abstracts a large set of task relevant data in a database from sorry, low conceptual levels to higher ones. Low conceptual level to higher ones is called the generalization. Here, say, let us have the conceptual levels, say 1, 2, 3, 4, 5. What do we say that we process where the abstraction is in the way that low conceptual levels to higher ones. Low conceptual level to higher ones. Then that is called the generalization, right? What do we say about this? Generalization. Here 1, 2, 3, 4, 5 is given. If we are having here, say low level concept, that is, for example, low level concept is, for our example which we were taking till now for area, you can say street is there, then after city is there, then after state is there, then after country is there, right? That's what we were taking till now, the example, fine. So low level concept, street is replaced with city, or you can say city is replaced with state, or state is replaced with country, right? So what do we say is low conceptual levels to higher ones. When we are going, it is called the generalization. Okay. So what are the approaches to do that? One is data cube approach, that is OLAP approach. OLAP is online analytical processing. And second approach is attribute oriented induction approach, right? What for? That is for data generalization, right? So let us see the data cube approach. So what is that? Perform computations and store results in data cubes. Perform computations and store results in data cubes. What do we mean by that? An efficient implementation of data generalization. That is very simple computation of various kinds of measures. As for example, count, sum, average, max. We can say that the data, say 100 data is there for any particular class, say we are having the marks, right? So what we want to get is, I want to get who people are having double A grade in my subject. Okay, so what I'll do is, first of all, I should have the data where people are having double A grade, and then I'll use the count, isn't it? That is, as we know that in SQL, because on database you are aware of that, on SQL you do have the count function with which you can get the count of those particular people who are having the grades in my subject as double A. Fine. If I want to find the sum, that is also one way to get the generalization. I want to get, say, what is the total salary or sales of this particular year. So what I'll do is, I'll consider sum of all salary per month, or you can say sales. If we consider, then sales of each month will sum it, right? So we can have the general idea. Okay, so this much profit, this much sales was there, isn't it? If we want to consider, like, for particular month, not particular month, average in a year per month, what was the gain? So for that, we can say, we can find the average. If I want to find what is the average result of your class? Hmm. Let us take average of the percentage what you are having in my subject. So I can have the idea that average, this is the percentage of your class, right? Maximum, if you want to get what is the max marks in this particular subject, you can use this one. Fine. So what we are doing is, using the data cube approach, we are considering the count, sum, average, max like measures to get the generalization. Fine. Okay. Now, this sum we have already used, right? If you remember, in the previous lecture, we have considered the sum, right? Whatever products were purchased over there, we were doing the sum, right? In the data cube. For data reduction, we have used this, right? If you remember, generalization and specialization can be performed on a data cube by roll up and drill down. See, till now we have used the word that is drill down. Drill down means we are going in the detail of a particular concept. Same way, if we go from low level to the high level, that is roll up, right? That is roll up and drill down, right? Roll up and drill down, fine. So they are the reverse processes of each other, but what we do for that, that is, we can say we are going from low level concept to the high level concept, that is the roll up. And when we are going from high level concept to the low level concept, that is in that direction, if we are going, that is called the drill down. Let me say that for roll up, let me tell you the example. That is, we can say roll up, where you can say we do have the concept that is in this manner. Say, suppose we are writing it in this manner, country, and you can say state and city, right? Suppose we are having this way, then roll up means we are going in this particular direction, right? We are going in this particular direction, that is from city to state to country, right? When we are going from city to state to country, this is called roll up. That means wherever, say Surat city is here, what we are doing is we are replacing that with, say, Gujarat. Gujarat is there, but we are replacing that with country, right? That is our India. So if it is so, we can say that it is roll up. And when country is there, India is there, but we want to see in the detail. Okay, India is there, fine. But what state is there? What city is there? So for that, you can say you are going in deep. That is, you can say drill down. Fine. So what do we say about the limitations? It can handle only dimensions of simple non-numeric data and measures of simple aggregate numeric values. See, we can handle the dimensions of simple non-numeric data. See, for non-numeric data, we cannot find the average. What do we want to say is, whenever we do have relation, like say subject marks, I want to get the data about what is the average marks. So for that, we can say we can be taking the subject name, that can be the non-numeric data, that is a subject name. But 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 the measures must be there in numeric values, right? The measures, whatever data is there, for that particular data, it must be numeric, right? So we can have the combination where we do have the non-numeric data, but there we will not be able to apply discount, sum, average, max, right? We can have the data about, say, customers, what type of customers are having this, so that answer we can get. But there we can have the values, that is, these functions can only be applied with the dimension where we are having the numeric values, fine. Attribute oriented induction, now what is that? Collect the task relevant data, that is initial relation, using a relational database query. What we are doing is collecting the task relevant data using a relational database query. Perform generalization by attribute removal or attribute generalization. Data aggregation is performed by merging identical generalized tuples and accumulating their respective counts. Fine, we know that for data aggregation, what do we do is we are generalizing the tuples and accumulating their respective counts, isn't it? Interactive presentations with the users, that is using charts and rules, fine. So here what we are doing for generalization, we are either removing the attribute or otherwise we are having the attribute generalization, okay. So what do we have? Attribute removal. If there is no generalization operator on the attribute, then remove that attribute. We do not have any generalization available for that attribute, then remove that attribute. Because what do we want to do is, we want to do the generalization. So there should be available the generalization for that particular attribute. Suppose area, for that we do have the generalization available. But if for any other attribute, like we were discussing for say year, then quarter, then weekdays, right? For that, we have considered month. For that, we have considered that the generalization was not possible. The concept hierarchy was not possible for those concepts. So for such attribute, we remove them. Do we remove them from the database? No. We remove them from further processing, right? We remove them from the further processing. We do not delete it from the whatever database is available. Fine. Okay. So what is the case? Next one is attribute generalization. What is that? If there is a large set of data of distinct values for an attribute in the initial working relation, then use generalization operator on that attribute. What it says, if there is a large data set of data of distinct values for an attribute in initial working relation. What do we see? Attribute generalization. Where are we doing? Or what we are doing in that? Do remember the example of automatic hierarchy generation, right? So for that, what we were doing is, if it has the large set of data of distinct values, if you remember, we were having the distinct values. Here you can see that these many distinct values are there. For street, these many distinct values are there. For city, these many distinct values are there. For state, these many distinct values are there. For country, right? So you remember that, isn't it? So wherever we are having such distinct values, where we can say large set of data of distinct values, right? So there we apply the generalization operator. Okay. The third one is attribute threshold control, typically 2 to 8 specified default. You can say attribute threshold control. That means some threshold is given to you, and then after we will be able to remove something, or we can say we'll consider only those where they come in particular threshold. 2 to 8, that is where say numbers are there, the label is given, say 2 raised to 0, 2 raised to 1, 2 raised to 3, that way if the label is given, or otherwise we can say whatever is specified by default, right? That is, say for your class, I want to get the data where they are having the percentage more than 50 percentage. Okay. So what is that? The threshold control is given. So I'll consider the data of only those students who are having more than 50 percentage of marks, right? Generalization relation threshold control. So what do we say about that? Control the final relation or rule size, right? Now threshold control is there on the generalized relation. What we are getting after applying say generalization operator, whatever is the generalized relation, on that we are giving the threshold control, and that is for, you can say, final relation or final rule size. Okay. say after doing some processing like attribute removal, attribute generalization, attribute threshold control, we have done all these things, right, for particular data set, suppose, and we are having the relation wherein you can say many rules are there. We can say bread, if people are purchasing, then they will purchase butter. Okay. If person purchase bread and butter, they will purchase cheese. And you can say 100 such rules are there. So which rules you want to have? For that, we can say that the rule size threshold is given to us, right? So I may consider the schemes for my shop wherein I will consider the specific items are having the count that is more than a particular one, or if I want to consider, say, I want to have the combo of 3 or 4 items only. So I'll consider that way. I want to consider rule size. That is, I want to accept only 100 rules. This way we can have the control. This way we can have the threshold. Isn't it? So that is one way to have the attribute oriented induction. Fine. Now we want to have the relevance measures. What are they? It is to help to identify irrelevant or weakly attributes that can be excluded from the concept description process. The relevance measures, they are the measures, what we say, they are irrelevant, or you can say weak attributes. Those will include, no, we will exclude them, right, from the concept description. Right? Quantitative relevance measure determines the classifying power of an attribute within a set of data. Now, these relevance measures are information gain. What is that? We will see information gain, then Gini index, then uncertainty coefficient and correlation coefficient. For correlation coefficient, we already know, we have studied that, but about these three, we do not know. Fine, we'll study them. Okay, so what are these relevance measures? They help us to identify relevant or irrelevant or weak attributes. They identify that and then we will remove that. So indirectly we can say that will help us to identify what are the relevant measures, right? So now we want to learn what is association mining. You can say, ma'am, here you have said few concepts: information gain, Gini index, uncertainty coefficient, correlation coefficient, but you haven't talked about that. That we'll study when we will see the classification, right? So, what is association mining? From where it has come from? The chapter title was Concept Description and Association Rule Mining. Fine. So, concept description, about that we have seen. Now we want to know about what is association mining. So, let us see that. People say it as association mining or association rule mining. Okay. So, association of items, it should be right. Then rule, okay, so from the association we are making the rules, and that's what we are mining from the data set, and that is what is layman's term to understand association rule mining. Now, a simple example which I am taking from this starting of this subject, that is, people who purchase bread purchase butter. This is what is my observation from the data set. How did I observe that? I have counted the items purchased for bread, how many times it is purchased. I have counted how many times butter is purchased, right? So this is what I have counted. How? That depends. You are using SQL or you are using any X procedure, but we are having the data wherein you can see that bread is purchased and butter is also purchased. That is in group. First of all, we find the separate count of the items. Okay, bread is purchased. Let me show you. Bread is purchased 100 times. Let me say bread. Bread is purchased, say 100 times. This is an example only, okay? Don't put it in your mind. Butter is, say, purchased 97 times. So, are their count is same? Obviously not, isn't it? Bread is purchased 100 times and butter is purchased 97 times. But, but, what about the combo of them? That is bread and butter. Please do not confuse with the this capital letter and the small letter. Okay. Many a times it is given as say breads and bread. So do not confuse with that. Okay. Say chocolate and chocolates. For bread we typically do not say, but say chocolate is written somewhere and somewhere the chocolates is written. That is s is only added. It is the same item. Okay. So do not confuse with that. What I mean to say is individually bread is purchased by 100 people. Individually butter is purchased by 97 people. That is what we count first, right? Now I want to check this. Both the items are purchased many times. Now many times means what? 100 is good one, 97 is good one, and if the number is 4 or 5, it is not good one, it is bad one. No, for that the minimum threshold is to be considered for a particular shop, for a particular problem statement. Fine. Now suppose here it is given say 75. For example, this is given. So what we have to consider? Bread is purchased for 100 times, but it is more than whatever is the minimum count given. So this item is frequently sold. Getting it? Bread is purchased say 100 times individually. We are not considering the combo just now. Okay. Butter is also purchased more times, but 97 times, and which is more than that of whatever minimum threshold count is given to us. Fine. Who give us this? Who gave us this? That is for particular problem statement for shop owner or whatever company you consider. Right? Okay. So minimum threshold is being decided by them only. So this is given to us. We can say that bread is frequently sold item. It is because it is greater than that of the minimum count. Same way for the butter. Same way for the butter. So we can say this butter and bread, they are the frequent items. Now let us consider both are the frequent items. Then let us consider the combo of it. So for that we can say bread and butter. Now what we have to do is we have to count the transactions of customers where customer has purchased bread and butter together. That means the transactions where we can have the butter, then you can say bread, you can have the chocolates in between, right? Order doesn't matter. Order doesn't matter. Only thing is both the items must be there. This is say transaction 1 of any customer. Say I am having transaction T2 of any other customer wherein I am having say bread, then after say kurkure, then after say we can say butter. Okay, so this way where bread and butter both are there. This is the butter, right? This is the butter item and this is the bread item, fine? So the transactions wherein bread and butter both comes together. Together doesn't mean that they are in this way only. The sequence doesn't matter. The order doesn't matter. Only thing is both must be available. Fine. So butter and bread, right? Whether it is there in this sequence or bread and butter, whether some other item is there in middle or not, that doesn't matter. Okay. So if this is the case, say these two transactions are there, we can say that in both the transactions, we can find both items together. So if I am having only this as the data set, I can say bread and butter both sold together. For that, I can say the count is 2, right? Whether it is crossing the minimum count, see here you can see it is the 75, but the transactions are only 2. Then what? This was for the other example where bread was sold 100 times. So at least 100 transactions must be there, isn't it? So do not confuse with these numbers. This is for the example. Now let us say that we are having 100 transactions. 2 I have shown, so some more are there. More are there, right? Many more are there transactions. You can say 100 at least are there. Now I can say that bread and butter is found in the transaction that is say 77 times. So can I say that these two items combo is frequent? Yes, I can, because their combo count is greater than that of what is given as the minimum count. Getting it? So this two items combo is frequent. Fine. And I can see that bread is purchased and people purchase butter also. Right. So that is the rule I am making. Not 100% times. Not 100% times. I am getting that people are purchasing, they will purchase butter also. But at least in many cases, I'll be able to say that if the bread is purchased, butter will also be purchased, right? For at least 77 people, I can say, right? Out of 100, isn't it? So that's what we need to calculate mathematically. And for that, after analyzing the things, we are giving the rules. That is, if people purchase bread, will purchase butter also, right? So that is what is association rule mining. The concept I have explained you using the example, right? Otherwise, all these things we will see in detail. Fine. So what do we say about the association rule mining is a procedure which aims to observe frequently occurring patterns bread butter combo together, right? For example, correlations or associations from data sets found in various kinds of databases such as relational databases, transactional databases, and other forms of repositories, right? So, what do we want to know? What background we want to study? Let us see that. This association rule mining, for that, it was proposed by Agrawal et al. It is called as Agrawal, comma many other people are there. So it is said as ETAL, right? In 1993, the research publications by a particular person and some more are there, that is written as Agrawal at L. Okay, and in a particular year. Assume all data are categorical. We are assuming that we means who assume that that was the Agrawal et al. Right? Assume all data are categorical. No good algorithm for numeric data. There, that was the background for this particular concept. Okay, so it is not so that whatever was assumed that is only there today also, but for particular algorithm it was assumed. Fine. Okay, initially used for market basket analysis to find how items purchased by customers are related. Market basket analysis. What is that? Market basket. That means we purchase everything from the market. Typically, whatever is the mall or anything is there, but it is considered as a market, right? Now, each and every customer buys something. Okay, each and every customer buys something. So they are having the basket with them. They are having the basket with them. In that we are putting, they are putting their items which they have purchased, right? So what do we do is this basket which contains the items which we have purchased from the market, those things are getting analyzed, and and we find how the purchased items are related. Fine. Till now we were talking of the example bread, butter, cheese, right? These examples we were considering. What is that? When you go to market, you purchase the items, you put the items in the basket. What we do is we analyze the basket of only one person? No, for all the customers. So where do we have all these things? Those things are there in the database or transactions, isn't it? At a particular shop. So we analyze them and we will be able to see people who purchase bread will purchase butter also. Fine. So for example, here we have considered bread implies milk. It means if person purchase the bread, it implies that that person will purchase milk also. And with what we can say this, that is SUP, SUP is equal to 5%, CONF, conf is equal to 100%. Now what is this? SUP and conf, they are the two important terms for association rule mining. They are the support and confidence. Fine. What they are and how to find them, that we will see further, right? So the thing which we are talking of just now, that is basket data. Let us see that. Retail organizations, as for example, supermarkets, collect and store massive amounts of sales data called basket data. For example, we can see the lady who is having the basket with her and she has purchased few items, right? This is one thing. See, you can say retail organization. So we used to think of the malls only, right? But now we can say we are purchasing everything from the stores, say Amazon store or any other, but we are purchasing through mobile, isn't it? So it is shown in the mobile, right? But the items we can see as we are having it in the store. Fine. So what we do is for all the customers of the shop, we do have such basket, that is we do have such transactions, and what we do is we analyze that, right? We analyze that. Okay, so basket data we do have. Our record consists of transaction date and items bought. Or basket data may consist of items bought by a customer over a period, right? Daily? No, no. Weekly? No, no. Monthly? No, no. Yearly? Right? Something like this. The data is there. Maybe we are having, say, exact date, or otherwise we can have the data wherein you can say that weekly the person is purchasing, say, particular item. Fine. Okay. So that is what we are having in the basket data. Fine. And then we will analyze that we do have the relation, and we can say we will find the rules of that purchase which people are doing. That's all for today.